for the opportunity to be here today. My name is Ebers Broughel. I'm an economist at Tetra Tech working on a variety of environmental and energy issues. Today's webinar is the second webinar in the series titled AI and Energy. The recording of the first webinar is available on the USAE website, and the sequel to today's webinar is planned for the 17th of August. The registration will be open soon for the sequel webinar as well. It's my pleasure to introduce today's speakers, Avi Goldfarb and Giuseppe Amoroso. Professor Goldfarb is the Rotman Chair in Artificial Intelligence and Healthcare at the University of Toronto. He's Professor of Marketing. He's also Chief Data Scientist at the Creative Destruction Lab and a Research Associate at the NBER that last year published a research agenda in the economics of AI. He's a co-author of a best-selling book titled Prediction Machines, The Simple Economics of Artificial Intelligence. Welcome, Avi. The second speaker today is Giuseppe Amoroso, who is the head of digital strategy and governance at Enel Group in Italy. He's been with Enel since 2008, where he has taken on different leadership and project management roles. Currently, he oversees governance of the Enel Group's digitalization program with a budget of over 5 billion euros invested over the past 3 years. He's guiding the company's path to data-driven transformation. His talk will highlight different approaches of machine learning and advanced analytics that's carried out at Enel. Thank you for joining. And welcome to our esteemed audience. Feel free to add questions in the chat box. These will be addressed during the Q&A after the presentations. And without further ado, I'm giving the floor to Professor Goldfarb.
Thank you. So it's a pleasure to be part of this webinar and to talk about our work on thinking about the opportunities in AI, and then I'm hoping through the Q&A we can think through how that specifically relates to the energy industry and energy economics. So this talk is based on a book that Jay Agrawal, Joshua Gans, and I wrote a couple of years ago. I'm trying to simplify and put a framework around what we'd seen in AI. So one of my titles is Chief Data Scientist at the Creative Destruction Lab. What is that? It's a program that we have at the University, originally at the University of Toronto, now at 7 other universities around the world to help startups scale. And in 2012, we saw our first AI company. And in the last 8 years now, we've seen hundreds of these AI startups, including many in the energy industry. And what this talk is and what the book came from was a combination of seeing these hundreds of AI-based startups with our framework that we see with our economics framework that we see the world. So there's no shortage of hype around AI. Everywhere you look, you see this expectation that AI is going to surge. At the same time, when we see this hype, we get anxious, right? If the machine's intelligent, what does that mean for us? Or we've accepted that machines are stronger than us, but we haven't accepted yet that machines are going to be smarter than us. And so both this excitement and anxiety are rooted in confusion. And what's the confusion? It's the confusion about what we're really talking about here when we talk about AI. The optimistic scenario that you might see in the press is something like C-3PO. C-3PO is an artificial intelligence. C-3PO is a robot in Star Wars that can do just about everything humans do. C-3PO does 2 things better than human. One, which they talk about in the movie, is that C-3PO translates from one language to the other. The other is not as obvious from the movie, but this is what makes C-3PO optimistic, which is that C-3PO is an artificial intelligence that listens to humans. And that's what makes that the optimistic scenario. The rest of science fiction, on the other hand, is filled with these machines, whether it's in the Terminator or 2001: A Space Odyssey or the Matrix, that can do just about everything we can do, but don't listen to us. So when you read about AI, this is where most people's minds go. But it's important to recognize that this is very little to do with the reason we're talking about AI in 2020. This isn't impossible. Someday this may happen. But truly artificial general intelligence has been 20 to 50 years away. since the very first AI conference at Dartmouth College in 1956, and it continues to be 20 to 50 years away. What we're talking about today is not artificial general intelligence. The reason we're excited about AI is because a very particular branch of computer science called machine learning has gotten much better. And we can think of that branch, we can think about that technology as prediction technology. And so what's changed is prediction machines. Prediction has gotten better, faster, and cheaper. To understand why that might matter, it's worth jumping back a generation and thinking about your computer. What does your computer really do? Feels like a computer does all sorts of things. It allows you to watch webinars. It allows you to take notes, play games, etc. But really, in essence, your computer does one thing. It does arithmetic. And then thinking through in 1995, when the real hype around the information technology era started to build, well, I can't see my audience, so I don't know how old you guys are, but I imagine some of you may not remember 1995. And 1995 was a very exciting year in technology. It was the year that the last aspects of the public internet were privatized. It was the year that Bill Gates wrote his internet tidal wave email and said, you know what, Microsoft, we miss this technology. And this technology, the internet, is the future of computing. And it was the year that Netscape had their IPO, and they were valued at over $1 billion that year without a nickel in profit. And so the hype kept building, 96, 97, 98. And in the press, people stopped talking about the internet like it was a new technology. They started to call it the new economy. Now, there was one group of people who didn't call it a new economy, and that was us. That was the economists, right? We said, no, you still need to buy our textbooks. Okay, of course, that was self-serving, but why did we say we still needed to buy our textbook? It's because once you understood simple economics, you could map out the consequences of the internet. If you knew that the internet meant that search was cheap, that communication was cheap, and that copying was cheap, you could figure out what would happen. Cheap copying meant, first and foremost, copyright was going to be a big deal, and we're going to have some issues around file sharing and piracy. Cheap copying also meant that privacy was going to be a bigger deal. This was forecast way back in the mid-90s by the leading economists thinking about the internet. For example, Hal Varian, who became chief economist at Google, and Carl Shapiro, who worked in the CA under Obama. They wrote a book mapping out these consequences and saying, you know what? Cheap copying means copyright's going to matter and privacy is going to matter. It's worth jumping back that other generation and thinking about your computer, right? So I've said, what does your computer do? It feels like your computer does all sorts of things, but we can represent it as a drop in the cost of a fundamental input. And that input is arithmetic. Your computer seems like it does all sorts of things, but it really only does one thing. It just does it so well that we found a whole bunch of applications for cheap arithmetic that we didn't think of before. But when computers first started to roll out, what did we use machine arithmetic for? In World War II and shortly after, we had effectively cannons and they shot cannonballs. And it's a really difficult arithmetic problem to figure out where those cannonballs are going to land. And so we had teams of humans whose job was called computer, who figured out the trajectory of those cannonballs and where they were going to land. The movie Hidden Figures was about these teams of humans whose job was called computer. But then machine arithmetic came along and replaced the humans. We no longer have humans doing those artillery tables. A decade later, in the 1950s and into the 1960s, it came for accounting. If you ask an accountant from that era what they spent their time doing, they spent their time adding. A homework problem that my colleagues in the accounting department at the business school in Toronto remember from their days as students is they'd ask you to open up the white pages, the phone book, to say page 962. And on page 962, there'd be something like 100 different 7-digit phone numbers. And the professor would say, add them up. Why did the professor say add them up? Partly because we professors are like that. But the students put up with it. Why did the students put up with it? The students put up with it because they knew that's what they'd be spending their lives doing. Accountants used to spend their time adding up columns of numbers. That's not the case anymore. Computers do that arithmetic for them. Turns out there's still lots for accountants to do, because the people who are best at doing the arithmetic also happen to be best positioned for using that arithmetic for tax strategy and company policy. Now, but as arithmetic became cheap, we started to realize we could use arithmetic for things that we didn't used to think of as arithmetic problems. Games are arithmetic. Mail can be reframed as arithmetic. Music is now solved as an engineering problem through arithmetic, and pictures are now solved through arithmetic. Right? Kodak was a chemical company. We used to solve photography with chemistry, but as arithmetic became cheap, imaging became an arithmetic problem. So that gets us to today's technology. This is a representation of a convolutional neural net. This is one of the core technologies underlying the current excitement in AI. And as I said earlier, we should think about this as better, faster, cheaper prediction. Prediction, starting somewhere around 5 years ago, has gotten much, much cheaper. What does that mean? Well, just like with arithmetic, the first applications of machine prediction are good old-fashioned prediction problems. You walk into a bank and you want a loan. 100 years ago, what would have happened? The loan officer would have looked you up and down, maybe looked at some paper that said that you had collateral, and would have said, yeah, sure, I trust you, or no, I don't. Over the last 100 years, that's become more, those predictions have become more arithmetic-based. But now, increasingly, those predictions about whether you're going to pay back your loan are done using machine learning. The insurance industry. The insurance industry is in the business of prediction. That's what they do. And increasingly, prediction machines, AI, is at the center of the transformation of the insurance industry. The industry that has been most engaged with us in our work has been the insurance industry, because prediction is what they do. And so understanding machine learning, understanding prediction machines is going to be fundamental to improving their business model. But as prediction's getting cheaper, we're starting to realize there's things we can do with prediction that we didn't realize before, right? Turns out medical diagnosis is prediction. We didn't realize that before, but you think about, what does your doctor do? They take in data about your symptoms, and they fill in the missing information of the cause of those symptoms. That's prediction. Image recognition is prediction. How do your eyes recognize a familiar face? They take in data about essentially the light signals, and they fill in missing information of a label in a context. We've had a company at the lab that ended up using AI to predict the water content of crude oil. You might think that's a chemistry problem. It sounds like a chemistry problem, but the water content of crude oil coming into a refinery can be a prediction problem. That can be, AI is one of the key tools that can be used to solve that problem. So up until now, for those, this is the US Association of Energy Economics. So you guys all remember your first day of Econ 101. So that means you all remember that all I've said so far is the demand curve slopes downward, right? When the price of something gets cheap, you do more of it. That's it. Step number one of understanding the economics of technology is that demand curve slope downward. And so when something gets cheap, we're going to do it more. And then the key challenge is to figure out what's gotten cheap. Okay. On day 2 of Econ 101, you learned about substitutes. On day 2 of Econ 101, you learned, well, yeah, when coffee gets cheap, we buy more coffee. Cheap coffee is bad for you if you're in the tea business. Okay. Tea and coffee are substitutes. So cheap coffee, bad for the tea business. What does cheap prediction mean? Well, if machine predictions getting cheaper and cheaper and cheaper, it's not good for you if you're in the human prediction business. If the aspects of your job that involve prediction are increasingly going to be done by machines. So what's left? Where are the opportunities? Where's the hope? In that same second class of Econ 101, you learn about complements. You learn that when coffee gets cheap, we buy more cream and sugar. Cream and sugar are the right businesses to be in when coffee is cheap. And so the right businesses to be in when machine prediction gets cheap, when prediction gets cheap, are going to be the complements to prediction. So what are the complements? What are the cream and sugar to prediction? To get your head around that, you need to know what prediction's for. Prediction's valuable because it's an input into decision-making. And it's decision-making that's a big deal, right? We make decisions all the time. Decision-making is everywhere. And so when we think about where's the opportunity in prediction, we need to recognize that prediction is not decision-making. And so it's the other aspects of a decision that are going to lead to the biggest opportunities. And so in our book, we lay out we summarize 50 years of decision theory into this handy little flow chart. And underlying it, this image is, predictions at the center. That's what's changed. And we have things like the ability to take an action becomes more valuable, different types of data. You've heard that before. But something that's a little bit unique about machine learning in particular, about AI in particular, is the value of what we call judgment. What's judgment? At a high level, it's knowing which predictions to make and what to do with those predictions once you have them. In particular, when we narrow it down, to understand it, I like to use this is my last science fiction example, I promised. Another example from science fiction, which is from the movie I, Robot. I don't know if you've seen this movie. It's a fine movie. It's not the best movie in the history of the world, but it has this fantastic scene. So Will Smith is the protagonist in I, Robot, and he hates robots. Okay, so that's sort of the plot. Now, there's this flashback scene about why he hates robots. Here's why he hates robots. He's in a car, there's a little girl, and there's a car accident. And it's pretty clear that both Will Smith and this little girl are about to drown in a river after the accident. Then a robot comes along and saves Will Smith and not the girl. And that's why he hates robots. What's interesting is because it was a robot making that life-saving decision, he could audit it. He could figure out, why did the robot make the decision to save him and not the girl? And what his audit finds is that the robot predicted that he had a 45% chance of survival and the girl only had an 11% chance. And so the robot saved him and not the girl. Will Smith says 11% was more than enough, and a human being would have known that. I don't know that all humans would agree that 11% relative to 45 was more than enough, but I can tell you he's saying something very particular. He's saying the prediction, right? The robot made the prediction of 45 versus 11. A human needs to make the judgment about whether his life is worth less than, or her life is worth more than 4 times his life. If she had an 11% chance of survival and he had a 45% chance of survival, if it's the right decision to save her, then her life is worth more than 4 times his. That's judgment. That's valuation. And that's something that for now remains the domain of humans. So the key complement, the biggest opportunity in using prediction machines is excellent judgment, ideally that can be scaled across many different situations. So what does this mean for the strategy of your organization? To get a sense of how better, faster, cheaper can change strategy, I'm thinking about this building, okay? This is the dominant building at the campus of the University of Toronto. It's the library, okay? It was built something like 40 years ago, and as the center of campus life. If you went to those librarians, say 40 years ago, and said, what do you think the most exciting company in the world is going to be in the year 2005 or the 2010 or even 2020? I bet you none of them would have said it's going to be a library science company. But it turned out when search got better, faster, cheaper, library science became the center of a huge industry. Google's a library science company. That's what they do. They help you look stuff up. And in fact, the original underlying algorithm was directly borrowed from library science. How does this transformation play out in the context of AI? I can't give you that great example yet because it hasn't happened. So we have to work with thought experiments. So let's imagine that there's a dial. And the dial is turning up the prediction, making it better and better and better as you get more data and the algorithms improve. So here's Amazon. Amazon makes incredibly good predictions already. They have hundreds of millions of products in their catalog. As far as we can tell, for every 20 recommendations they give, they get one of them right. Their predictions are 5% accurate. But with hundreds of millions of products in their catalog, that's incredible. Their excellent at using machine learning, using prediction. But it's not transformative to the business model. Amazon is in the same business they were in when they started, in 1994. And in fact, they're in the same business they were in that the Sears catalog was in well over 100 years ago. Amazon's a catalog company. They're a great catalog company, but they're a catalog company. Go to their online catalog, you order something, they send that to their warehouse, and they ship it to your door. Now imagine if those predictions, instead of 5%, were 10%, 30%, 50%, 70% accurate. At some point, they don't need to be a catalog company. At some point, they'll know what you want well enough that they'll just send it to your door. They don't have to be 100% accurate. They just have to be accurate enough in order to make it worth it for them to build an infrastructure for returns and to bypass warehouses, their warehouses and other things. In case, let me be clear, I have no idea if Amazon's really going to do this and if this is going to work, but I do know they've thought about it and they've been thinking about it for a long time. Here's a patent from 7 years ago for anticipatory packet shipping from Amazon. And so in whatever industry you're in, you can play this game of science fictioning what it's like for your predictions to get better and better and better. And what does that mean for how to transform your industry? Thank you.
Thank you, Avi. Really appreciate it. Wonderful presentation. Based on the picture of your Amazon purchases, I predict that you really like baseball. I wonder if I got it right or it fell under the 1 out of 19 correct predictions.
I have an RA who really likes baseball.
Got it. Okay. So thank you for the presentation. I'd like to encourage the audience to use the Q&A button. This will allow us to see the questions and pre-sort them, make sure that we address as many questions as possible and group them. And without further ado, I'd like to turn the floor to Giuseppe Amoroso.
Good morning, everyone. I'm very pleased to be with you today. So let me try to share my screen. That's the most difficult task. Okay. So my name is Giuseppe Amoroso, and as Anna was saying, I'm leading the digital strategy and governance function at Enel. Enel, it's a multinational group based in Italy. That is one of the leading actors in the energy sector worldwide. So when it comes to the distribution business, so we are, I would say, by and large, the first network operator by number of end users, and our 2.5 million kilometers of electrical lines are serving more than 74 million end users in the countries where we operate. And we are also the world's largest player when it comes to the renewable energies, but a renewable capacity in excess of 45 gigawatts installed. And we have also very large retail customer base in the 30 countries where we operate today. And we can count on 70 million customers buying our products and services, so both commodities and energy-related services. And at the center of our strategy, we put since 2015 the digitalization. Why? Because we think that thanks to the digitalization, we can improve the way we interact with our customers, and we can also improve the way we operate our assets, and we can increase the engagement of our 70,000 people working with us 24 hours a day, I would say. And in order to do that, we defined a digital strategy that is actually based on the cloud migration of all our applications. So we are, thanks to the cloud transformation, we are now, I would say, a much more flexible organization when it comes to the development of new IT application and to replace the legacy ones that are no longer, I would say, able to respond to our needs. And another pillar is the development of global platforms, thanks to which we are standardizing the way we operate all around the world. And you know, the larger the digitalization program you are managing, then the higher is the risk exposure given the cyber threats. And this is why, so we have introduced in the way we develop our applications, so what we call the cyber security by design approach. In order to manage our digitalization program, we have embraced what we call an agile approach. So we are putting together people coming from the business functions, together with the people coming from the technological departments or the IT function, and together in the same virtual room, they're actually responding to business needs leveraging on digital technologies. And we put at the center of our digitalization program what we call a data-driven approach. So we want to become a data-driven company that is actually a place where the most important decisions are taken based on insights coming from the data we are producing in our company. And this is why in 2019, we launched a program whose payoff is data is powering our hands, because it's actually how we see our future. So we see a future in which the power of data will be much higher than we have registered so far. Why? Because the amount of data we are producing is increasing every day. Think about 24 hours in Enel. So we are receiving from our renewable plants more or less 40 million data records that we process every day to manage our operation and maintenance process. And we are retrieving from the field 26 billion load measurements that are produced from our smart meters and then delivered to our central systems in order to feed our IT softwares and to process all data we are actually receiving. And we are interacting with our customers 1.6 million times per day. And you can see by leveraging on this impressive amount of data, we've been able in the last 10 years to increase the amount of data by 20 times. So the level of the amount of data produced in 2019 was actually 20 times the level of data produced 10 years ago. And this is why we thought that in order to make us able to extract value from data, we needed to have what we call a data-driven journey. Data-driven journey that is based on developing and defining a data governance framework. So the set of rules, processes, roles, responsibilities, and IT tools that can allow you to have a proper control of data in your company. Then you need a data platform. So you need technology to process data and to get the most from the data you are producing. And you need know-how. So we need what we call a data factory that is made up of people capable of delivering results from processing data we are producing. And finally, the most important thing, the data culture. So you need to have your people changing the way they work, because rather than leveraging on our gut feeling and our experience, may be gained in the field, given the fact that we have a very strong technical and engineering background, you need to have people convinced about the fact that algorithms and what we call augmented intelligence can help them in taking the right decision at the right time. And it's actually the most difficult thing to do. Then data governance. You need to know what data you're producing. And this is why we have introduced in our company a data catalog. It's a very simple tool that allows people who needs to get access to data to understand, so what kind of data we are producing in the company, so who's the data owner, so all the features related to our data sources, in order to understand, so which kind of analysis can be done. And then we have complemented the data catalog with some tools that is actually focused on ensuring that the proper level of data quality is ensured all the time. Otherwise, you might have the risk of taking the wrong decision based on, I would say, the wrong data. And afterwards, we have been working to make up our data platform. So we are coming from a situation in which each single business line, so you can see the distribution business, then the analytics business, and so on and so on, was developing their own solutions based on their own data. Then Pacman jumped in the discussion, and we realized the fact that by having this silos approach, so we were actually missing a lot of value. So this is why ensuring compliance with all applicable regulations, laws, and so on, we have developed a data platform, a global data platform that, leveraging on all data we are producing in the company, is offering to the final user basic feature that can be combined among them in order to have then a solution up and running that is able to process data and deliver insight and results. And in order to do that, we had to build a global data factory made of very talented people that we hired from the market. But then we realized the fact that, it's a very fast-changing sector in which you cannot be sure 100% that you have in-house all needed know-how and capabilities. So this is why we have created a very open ecosystem in which we are collaborating with our innovation hubs, startups, universities, and we have created a AI data community that is actually giving us the possibilities of getting access to the needed know-how all the time without caring too much about the fact that it's an internal person or an external company which is cooperating with us. And finally, data culture. So we begin with the training, so a very specialized training and then a very generalistic training to, I would say, spread all over the world in our organization. And then we move to communication, to tell real stories about the job that is being done by our people, and to let people understand which is the actual power of data. And finally, we have created a community made up as of today of more than 300 people, putting together all our people that have something to do with data. Why? Because this is the right way to be sure that they are sharing experience and sharing I would say, a receipt about how to solve problems and about how to take opportunities from the impressive amount of data we are leveraging in our company today. And let's now go to the practice, I would say. So we are using AI along all our value chain. So starting from the assets, so the very first example of AI developed in our company was related to the predictive maintenance of our power generation assets. So we started developing what we call anomaly detection algorithms in our gas fueled power plants by looking at the standard behavior of specific components in order to spot something that can give you an early warning about something that is not going in the proper way. But then we moved also to our customer base, developing, for instance, algorithms that are looking at the behaviors of our customers in order to prevent the churn of our customers. And by delivering tailored and specific retention campaign in order to be sure that, you know, our customer will not leave our company and will choose another provider. And then all the supporting functions are relying on AI in order to have, for instance, financial forecasting done in an automatic way every month. For instance, we are using nowadays an algorithm that is capable of delivering the monthly rolling forecast in a completely automatic way when it comes to the OPEX for the generation assets or for the labor cost of our workforce. Let me spend the next few minutes to give you some practical examples of what AI in Enel is. And I would like to start from the power generation. Presago is an algorithm that we have developed to tackle the problem we have with the maintenance of our hydropower plants. So we have developed a predictive maintenance tool that is actually open to the operation and maintenance colleague that suddenly become data scientists, because, you know, they are the main actors of this tool. So they have to select the key diagnostic indicators to be used then to spot problems that can eventually lead to a failure with one of the components of the power plants. And they can use the tool to optimize the maintenance schedule so that having, I would say, the higher level of production and the lower level of unavailability of our power generation fleet. Let's move to another example. We have a lot of documents coming in our, for instance, distribution companies in order to have requests of information or claims, for instance. And then we have developed an algorithm that, using deep learning, is processing in an automatic way all the documents we are receiving in order to retrieve all needed information to feed a bot that is actually able to respond to the request for information or the standard request in an automatic way. And then, you know, the final example, so we are an energy company. So we are actually active in many countries. And one of our main concerns, of course, is related to our external reputation. And this is why we have developed a sentiment analysis algorithms that is actually looking at all possible data sources, for instance, social network, media, and so on, in order to understand whether we have some critical situation that has to be handled on the field by our managers, and is giving you details about, you know, what the actual problem is. Then data is power in our hands is actually the way we see our future. And I really thank you for the attention, and I really thank you for the opportunity.
Thank you, Giuseppe. Appreciate it. We have several questions that are now pouring in to address, and Professor Goldfarb kindly addressed some of them already, but feel free adding more questions. We have about 20 minutes for discussion. We can start with, to give Giuseppe a little breather, we can start with a question to Professor Goldfarb. Can you tell us, please, a little bit more about reinforcement learning and what your future vision for that is? And perhaps when you're at it, tell us an example of how crystal ball is different from a prediction machine, to clarify that.
It turns out those are very related questions. What I'm calling these prediction machines, by prediction, I mean statistical prediction, which is using data that you have to fill in data you don't have. So the AI that we have today, these machine learning models require a lot of data. You just saw that from Giuseppe's talk, right? The first half of the talk didn't seem like it was about AI, it was about data, but it was actually about AI because that's what you need in order to, you need great data to build an AI. And so the AI is only going to predict on the support of the data that you have. And so that's what I mean by, a crystal ball is just a prediction about the future. But if you don't have data on situations like that in the past, or if it's never happened in the past, today's AI is not going to help you. At least the AI for the foreseeable future is not going to help you very much for that. What's reinforcement learning? So reinforcement learning is a tool for proactive data collection. So the way you can think about reinforcement learning is it's a complement to deep learning, which is the core technology underlying the excitement in AI today. What reinforcement learning is a way to tell the machine which data to go out and collect in order to improve your prediction models. And so it involves explicit experimentation to collect data that's not currently in the support of the data. So the classic example of reinforcement learning is Google's DeepMind, and in particular, the AlphaGo victories. So there's this game Go, it's a board game. It has a lot of possible solutions. Google simulated millions and millions and millions of Go games in order to figure out what the best strategies were. And what was interesting about the reason this was reinforcement learning is the machine started with very little knowledge of how to win. And essentially by randomly playing different moves in millions and millions and millions of games, it learned the best strategy. So it proactively collected data in order to learn what worked. And that's what reinforcement learning is, the way to proactively collect data to improve your prediction models. And so when we think about the future of reinforcement learning, it's the ability to go out, to which sort of is a complement to thinking through good organizational practices in leveraging AI, which is you go out, you experiment in order to learn how to do things better.
Thank you for addressing this question. The next question is for Giuseppe Amoroso. And the audience wants to know more about business models of the future in the energy sector.
Okay, so we have, I would say, different examples that can let us understand how the future will look like. Because when it comes, for instance, to demand response, then artificial intelligence is something that can help in building up new business model that can offer, I would say, the management of flexibilities, leveraging on the impressive amount of data we are retrieving from the grid, from the electric vehicle infrastructure, recharge infrastructure, so from the, I would say, load consumptions, consumption behaviors, and so on and so on. And to me, the flexibility and the demand side, I would say, management, it's something that can be, I would say, disrupted by AI and can lead to new and innovative business models in our sector. But I would say it's true that also the traditional sectors are being disrupted by AI. Things about, for instance, the photovoltaic panel management. So you can spot a failure in a very large solar field by using an algorithm that is able to understand which is the voltage curve related to a specific string of solar panel. So you don't need to send people on the field and to spot each single solar panel before understanding what's going on. So also in this case, I would say new business models can be, I would say, seen in the near future that will help us in reshaping the way we manage the operational maintenance of our power plants. So a lot of potential value to be unlocked, I would say, and the energy sector to me actually is one of the sectors that can benefit the most from the application of these techniques.
Thank you for this response. And the next question is to both of you. And I feel that it's a common conception that AI is a luxury good, that it might be useful for large organizations. So our audience wants to know your thoughts on how small organizations can leverage the benefits of AI, especially given their limited funds and knowledge. Avi, would you like to address that first?
Sure. So let me start with an example. So I worked with an organization called the Property Valuation Services Corporation of Nova Scotia. Okay, they figure out what property taxes should be in a very small province in Canada, and they're world leaders in using AI. Okay? That's their whole staff is less than, it's probably less than a tenth of Google's DeepMind staff in one of their offices. So how is that possible? Well, it turns out there's a lot of big opportunities for prediction. And if you know your industry well, the AI doesn't have to be that doesn't have to be cutting edge. This technology works. And so it has to be good. So they hired a local statistics professor from a university in Halifax, and they hired one other person in-house to help them do this. They had good data. They invested in organizing that data in a way that would be helpful to the business, and they made it happen. And in the utility context, and actually a lot of the energy context, you're in a similar situation. You have the customer relationship, you have data, you have the sensors. The underlying machine learning isn't difficult. These are open source algorithms. You don't need to be doing the same things that Google's doing in order to get extraordinary value out of machine learning and beat the competition.
Thank you. Mr. Amoroso, would you like to address that too?
I would say I share the point actually. To me, the most important thing is to spend time and invest effort in making sure that data are properly organized, data are available, and I would say data quality is ensured. Then you need know-how. This is, I would say, for granted, so you cannot set aside to have specialists in manipulating data and handle data. But then you don't need to think about becoming, I would say, the next Elon Musk, I would say, company before taking advantage from the insights that you can retrieve from data. And so this is actually, I would say, not so related to the size of the company or to the history of the company and so on and so on, but it's very much related to the culture of the way the company is actually operated. So if you think that data is actually power in our hands, as we used to say, then for sure you can find, I would say, a lot of space, regardless, I would say, the size of the company and the history of the company itself.
Can I just add one more point there, which is that sometimes small organizations have an advantage, which is that in large organizations, the data exists in many different parts of the organization, and you need cooperation from this VP and that VP and that executive VP in order to just do anything to combine the data as needed to build your AI. In a smaller organization, the data tends to sit all together, in which case some of the barriers are much easier. The organizational cultural barriers are lower in a small organization relative to a big one.
Thank you.
Yeah.
The next question is about AI being a black box in a way. The audience would like to know, given that uncertainty analysis that models many, many different scenarios that are not deterministic, given that this capability is now available with machine learning and AI, how does this change data presentation in general, and also for the purpose of decision-making in business strategy? And Giuseppe Amoroso, if you'd like to address that first, and then I'll give the floor to Avi.
Okay, so it's actually true. So now I would say the computational power is actually very, very cheap. So if you are a cloud-based company, then you can get access to very powerful machine in a second, I would say. So without having the need of involving people from IT and so on and so on. To me, it does not imply in an automatic way that the quality of the analysis will be higher than it was before. So the quantity of analysis will be higher for sure, but then you need somebody who's able to manage the link between the data scientists and the business decision making person, translating the need of the business person in order to be sure that we are not delivering too much information to the business person that can be, I would say, not so relevant from them, and can, I would say, bring the risk of losing focus on what the data that are insightful for our job are. And so data presentation for the purpose of decisions, to me, must change in a way that will be based on a larger amount of information, a larger amount of analysis, but has to be driven by somebody who has a deep business knowledge in order not to have the risk of losing focus for the sake of, I would say, analyzing data, for the sake of being data scientists and so on and so on.
Thank you for this comment, Avi.
I don't think I have much to add, except that I fully agree that start with the problem, the business problem. If you don't have a good business problem, then you're going to waste a lot of money and energy on making an AI for nothing.
We have a couple of interesting questions about the consumer, energy consumer, all of us. First of all is, who owns the consumer data? Is it the provider or is it the consumer? And the second follow-on question to that is, how is it possible to perhaps monetize this consumption data? And this might be something that Giuseppe Amoroso may be able to address the best, but Avi, you're welcome to chime in.
So the consumption data are owned by the consumer, I would say, but are also used by the distribution companies to understand how to manage the proper balance into the grid, and are also used by, I would say, the retail company, the ones which are selling the energy, then to make the bill, to invoice, and so on and so on. So you can have different use cases. When it comes to the retail company, then you can look at the, I would say, a load profile of a customer in order to understand what the consumption behavior, standard consumption behavior is, and maybe you can build up a tailored offer based on that specific consumption behavior. The distribution company can use an algorithm that by looking at, I would say, what the standard consumption is, can spot, for instance, fraud. So we are using AI to manage our fraud management processes. And if you have something that is actually changing the normal way you are consuming energy, it can be seen as a signal of a possible fraud, for instance. But it can be used by the distribution company also to understand how to ensure the proper balance of the grid in case you have, I would say, an excess of demand or an excess of production into the mid-voltage grid or low-voltage grid. And then the consumer itself can also use AI to understand how to optimize its own consumption by looking at its own load profile and by analyzing the way each single allowances is actually contributing to that specific load profile. So a lot of use cases, one owner, different users.
Thank you. Avi, would you like to add to this, or should we move to the next question? Next question. So we're on top of the hour, so that would be also the last question. And the question brings it all back to economics and the role of economists in helping drive this digital transformation. And this is for both of you. Avi, would you like to start?
So as economists, we have a very useful perspective. And that perspective is different from the perspective of the computer scientists and the engineers. And typically there's, I think about it in the context of leveraging AI, I think there's three advantages economists bring. So number one is we start with the problem and not the technology. So we try to think through, how is this going to be useful at the margin for the organization in order to improve outcomes? Okay, so just focusing on the technology as a tool, as opposed to the technology in and of itself being exciting in order to help the organization. Thing number two that economists bring is an understanding of equilibrium, okay? And so a recognition that, hey, if we do this, it's not just going to affect that little part of the organization. It could actually have consequences throughout the organization and throughout the industry. And trying to think through those broader equilibrium consequences is useful. And three, because economists have a very small number of models that work really, really well, like demand curve slope downward, and complements become more valuable when the price of something gets cheap. Things like that. Those models sort of help us do number one and two, which is identify the right business problems for technology. It's not, oh, this technology is cool, I have a hammer, I'm looking for a nail. It's, I understand that this technology represents a drop in the cost of prediction. Let's look for our prediction problems and figure out how that can be transformative.
Mm-hmm. These are all very compelling reasons to hire economists. I will agree with you. What from the business perspective, Giuseppe Amoroso, would you like to add anything to this?
I would say I 100% agree on the fact that you need to start out from the problem. So what we have found a process in our company that is actually starting from the definition of what we call a business challenge. So what the problem is, and then what the possible answer to this problem are. And one of them can rely on AI. And, my fear is that since we are talking about a very fancy and trendy topic, in some cases, we can miss the opportunity of doing very simple things because, we need to prove that we are testing AI, we are deploying AI, and so on and so on. So it is not the solution for, I would say, 100% of the problems, and in some cases is not the cheapest one. So take care. This is my personal recommendation when you have to approach this the sector.
I would like to close the webinar with a word of thanks to both of our esteemed presenters. And thank you for the audience. Thank you to the audience for dialing in. The recording will be available shortly on USAE website. And I'm handing over the floor to Rebecca or Lily of USAE to close the session.
USAE wishes to thank Dr. Anna Ebers Broughel and our distinguished panelists for an outstanding webinar. This webinar will be available on USAE's website for future download. If you are not a member of USAE, we encourage you to join by visiting www.usaee.org. We thank you for attending, and I now officially close this webinar.